Good morning, everyone. So we'll get rolling here. So my name is Dan Bromberg. I'm the Director of Academic Programs for the Carsey School of Public Policy, and I'm an Associate Professor in Political Science and in the Carsey School. We're thrilled to have you here for our conversation this morning at our Coffee and Conversations. For those of you that don't know, Coffee and Conversations is a discussion series jointly organized by the Carsey School of Public Policy, the State of New Hampshire Bureau of Education and Training, and the New Hampshire Association of Certified Public Managers to engage public service professionals in learning, problem solving, and collaboration. We're really thrilled this morning to have two great speakers to talk about the topic that we're titling Climate Change in New Hampshire, Why Do We Care? And what should we do about it? So we have two authors who are joining us today of the Climate Report, Dr. Mary Stampone, who's an Associate Professor of Geography at the University of New Hampshire. She is also the State Climatologist for New Hampshire. And I'm going to let Mary and Dr. Cameron Wake tell a little bit more about themselves. Dr. Cameron Wake is a research professor at the Institute for the Study of Earth, Oceans, and Space and the University of New Hampshire, at the University of New Hampshire, and is also the Joseph A. Lamprey Professor in Climate and Sustainability at the UNH Sustainability Institute. So we're thrilled that they are able to join us this morning, talk about both their report, but also open up a dialogue with all of you. So what we're going to have this morning is a relatively brief presentation, and then we're hoping to have a larger conversation. What you can do is take a look at the chat feature on the bottom of your screen, the Q&A on the bottom of your screen, and you could post questions in either one of those, and we'll help facilitate that conversation. This should also be an accessible conversation, so your closed captioning feature should be available for you. Should anyone need that, please feel free to do that, and we'll throw that into the chat as well. So I'm gonna turn this over to Mary and Cam. Really looking forward to this talk, and we thank you both so much for joining us this morning.
All right, well, thanks, Dan. So before we bring up the slides, Mary and I will introduce ourselves a little bit more. So I've been working on issues around climate change for at least 3 decades. And back in the 2000s, I began to get very interested in what was happening on a more regional level here across New England. And so as part of that effort, I've investigated sort of various historical records and instrumental records of climate change across New Hampshire and New England. Early on, I helped write New Hampshire's climate action plan back in 2009, which I still think remains in sort of an excellent report and provides guidance for what the state should do. And that was done sort of with multiple stakeholders from across the state. And then we worked on an assessment for New Hampshire back in 2014. And this most recent report was an effort that New Hampshire Department of Environmental Services asked Mary and I to take a hold of in a big part to really, because there's significant concern around New Hampshire's water resources. So I've been at this a long time, and it's just really happy to be here today to share our most recent report. Mary, over to you.
Hi, thanks, Cameron. So I'm Mary Stampone. My primary appointment here at UNH is in the Department of Geography, where I'm associate professor there. I teach courses mainly on weather and climate, as well as natural hazards. But then also part of my job is to be the state climatologist, which is kind of part of the kind of an extension type position where I've kind of combined sort of my general faculty type of research to have more of an engaged and a more state to local level impact. So a lot of my work is, like Cameron, focused on kind of regional, state, local scale change monitoring, as well as using model projections, and then also kind of impacts and informing sort of state to local level decisions regarding adaptation and hopefully mitigation. Today, we're going to kind of give you a brief summary of the state climate report that Cameron mentioned that we worked on. It was published this summer. So we're going to give you a little summary of the change we've seen, and then we can, of course, talk about kind of why we care and what we do about it.
I should also mention, because of sort of the public policy nature of these conversations, I'm also the chair of Kittery's Climate Adaptation Committee. And so in addition to thinking about sort of the scientific aspects of climate change, I'm also working with a wonderful group of individuals in the community I live in to try and figure out how it is we reduce our greenhouse gas emissions and adapt to change. So I am coming at this issue from more than one perspective. So this is the cover for the report that Mary and I wrote along with our colleague Liz Burakowski. And that link at the bottom there to scholars.unh.edu, Sustainability 71, is where you can download the report. So our goal today is to provide you with an overview of the main findings of the report. It's actually a very, very detailed report, and we went into quite a bit of depth, and you'll get a sense of some of that depth as we talk, but we're not going to cover everything that we wrote up in the report. So for more information, please have a look at the report. And I know authors don't say this very often, but Mary and I feel that the appendix section of the report is really useful for local communities, because that's where communities are going to get site-specific information on how climate has changed in their community and how it might change in the future. And we did that for 10 communities across New Hampshire. And so your community might not be there, but there'll be a community close to you that's certainly in your climate zone that you can look at. And for the most part, the results are a little bit transferable over sort of tens of miles. You can't take one of our sites and decide what's going to happen on top of Mount Washington, but aside from that, it's going to be pretty good. So we really framed this report in the way that many of the Intergovernmental Panel on Climate Change reports have been framed, as well as the national climate assessments in the United States. And so we collected all of the historical data, we've analyzed meteorological data, and we've analyzed that. And then as we projected out in the future, we looked at 2 different scenarios of greenhouse gas emissions. And we have to go down this scenarios pathway because we don't know what society is going to do in terms of emitting greenhouse gas emissions. That's one. And 2 is we know that the main driver of change in our climate system is a result of human activities, primarily from the burning of fossil fuel, but also because of significant land use change, as well as sort of agriculture around the globe. And so as in the IPCC and National Climate Assessment reports, we've looked at sort of a scenario that results in about 4 degrees of Fahrenheit warming, which is sort of a middle of the road scenario, but one that represents a future where we invest in renewable energy and we invest in energy efficiency. And we're calling that the lower emissions scenario. And you can sort of picture this as the scenario that the IRA, the Inflation Reduction Act that was passed in the United States, is hoping that we will be on. In scientific terms, it's called the representative concentration pathway that leads to 4.5 watts per meter squared. Let's just call it the low emission scenario. And then the other is the higher emissions scenario, where we continue to rely primarily on fossil fuel for all of our energy, and that leads to much greater warming. So we've got sort of this 4 degrees Fahrenheit warming, and that's sort of from pre-industrial times, and then there's 8 degrees Fahrenheit warming, low emissions and high emissions. And the main conclusions of our report are written up there on the slide, right? New Hampshire has gotten, not yet, Mary, thanks, has gotten warmer and wetter through the 20th century and up to 2020. And we are going to continue to get warmer and wetter with some interesting tweaks in that, because we're going to be getting much hotter in summer with not much more rain. We project that we're likely going to see more short-term drought. And we'll talk about that in a little bit of detail. But we've gotten warmer and wetter, and we're going to continue to get warmer and wetter. And then secondly, the magnitude of the change, as I've already indicated, depends on how much greenhouse gas globally gets emitted into the atmosphere. And so if we follow the low emission scenario, we're going to have less climate change that we have to adapt to. And in fact, the most important mitigation strategy, and when climate scientists say mitigation, we're talking about reducing greenhouse gas emissions. The most important mitigation, the most important adaptation strategy is actually to reduce our greenhouse gas emissions. So this is a big frame for the report: low emissions versus high emissions, and then what the climate impact, what falls out in terms of climate change as a result of comparing those two. Next slide, Mary. So here's one example of one of the indicators that we developed for the report. These types of, there's many of these graphs in the report itself. So what you're seeing here is a graph from 1900 up to 2099. The black line represents the historical observation. So here we're looking at New Hampshire average annual maximum temperatures, right? Then the black line is from 1900 up to 2020. And you can see that since around 1970, we've seen sort of a significant increase in those temperatures. There's behind the black line, there's a whole series of gray lines, and that's just the model output for the period, for the historical record. And that's just to make sure that the model output is actually capturing the local change that we see across New Hampshire. You can see in the near term, from the 2010 to 2039 period, we're projecting an increase of somewhere between 2.2 to 2.4 degrees Fahrenheit. And you can see in the dark blue line, it's the ensemble mean for the global climate model simulations that have been run on the low emission scenario. And then in the red, it's the global climate model simulations that have been run on the high emission scenario. Essentially what we're showing in the bold line is the average of 29 different global climate model simulations, and they have all been downscaled, statistically downscaled to New Hampshire, and we can talk about that if you want to. So you can see by 2010 to 2039, we have this sort of warming of 2.2 to 2.4 degrees Fahrenheit, and there's not much difference between the two scenarios. And so that is the amount of warming that we've locked into the system because of the inertia in the climate system and the length of time that carbon dioxide spends in the atmosphere, which is well over 100 years. If we in fact do begin to follow the low emission scenario, where we begin to see the separation is sort of around 2050 and beyond. And so if we follow that low emission scenario, by the end of the century, we could see warming sort of on the order, and this again is in annual maximum temperatures of 5.4 degrees Fahrenheit. Whereas if we follow the high emission scenario, we're going to be something up sort of closer to 10 degrees Fahrenheit. So a pretty significant difference there between the low and high emission scenario by the end of the century. And again, that leads to different levels of adaptation in terms of that warming. So this is this represents the detail that's provided in the report that I mentioned early on. And so I wanted to walk through this a little bit to show you sort of the extent of this detail. So what Mary and I have done is we've developed 31 different indicators for how our, to better illustrate how our climate might change in the future and how it might impact different communities. So first in this slide, you can see on the left-hand side, there's a map of New Hampshire, and you can see all of the different sites that we collected the meteorological data and that we then downscaled the global climate model simulations to. And you can see we have a good coverage across all of New Hampshire. And we do have Mount Washington on there because we do share some results from the meteorological data that has been collected on Mount Washington. So feel free to visit the report if you want to know what's been going on there. But no surprise, it's been getting warmer there too. And then these tables are we've developed these tables for every one of these communities. And this one we're looking at for Portsmouth, New Hampshire. So we just pulled out this as an example because many of us live in the seacoast area of New Hampshire. But again, these tables are available for all of the communities listed in the map. And so you can see on the left-hand side, we have the climate indicator. We've done sort of the traditional indicators, maximum temperature, and we've done that seasonally and annually. We've got minimum temperature. We've done that seasonally and annually. And we've got precipitation, and we've done that seasonally and annually. And just let me take you through one of these to show you sort of the extent of change and the difference between the low emissions and the high emission scenario. So if you look down under minimum temperature, the first line says annual T-min, and then the second line is winter T-min. So this is a place where we've seen the largest warming across the state of New Hampshire. So winter minimum temperatures, the historical average from 1980 to 2009 is 16.1 degrees Fahrenheit. As we look at in the future, we can see that in 2010 to 2039, we're going to see those numbers increase by 2.7 to 3.1 degrees Fahrenheit, depending on if we're in a low and high emissions scenario. By the middle of the century, and I would say this is sort of a pretty good planning horizon, we're relatively confident in these results that we're going to be somewhere in this ballpark by the middle of the century because of the inertia in the climate system. we're going to see a change somewhere between 5.1 degrees and 6.8 degrees Fahrenheit warming. That's a significant amount of change in our wintertime temperatures. And why do you care about wintertime temperatures? Because they get rid of pests. And when we don't have those really cold temperatures, things like Lyme ticks, things like hemlock woolly adelgid, things like other weeds that might attack our crops are going to be more prevalent in this area because we don't have those cold wintertime temperatures. It's also going to be harder to make snow. There's going to be less lake ice and river ice to skate on. There's going to be fewer days to go snowmobiling. And so you can get a sense that this one indicator actually has lots of impacts. And then just looking out at the end of the century, you can see that the warming underneath the high emission scenario is 11.1 degrees Fahrenheit. Under the low emission scenario is 6.4. So that's where we see that real separation between the low emissions and the high emission scenario. And so again, depending on what's of interest in your community and what decision you're trying to make, you could look at sort of this range of indicators and see what's important. We've got, right, T-max might be valuable for you. Next slide, Mary. So this is sort of a continuation of the same table, but now we're looking at the lower half of it. As a result of several stakeholders, we included heating degree days and cooling degree days, which is an important metric for energy use. So how much oil you might need, or how much for heating, or how much electricity you might need for cooling in the summer. And then we've also got a whole range of extreme temperatures and extreme precipitation. And those extreme temperatures are maximum temperatures and minimum temperatures. And so essentially what the table is showing you is that maximum temperatures are getting higher and warmer, and minimum temperatures are getting higher and warmer. But we have some really important metrics like days above 9 degrees Fahrenheit, and 3 days in a row for 9 degrees Fahrenheit is considered a heat wave. And so if we look at that sort of in the middle of the plot here, you can see going out, traditionally we have about 11 days. By the middle of the century, it looks like we'd have an additional 17 to 27 days. And by the end of the century, we might have 23 to 53 days. So at the high emission scenario, 53 plus 11, sort of 64 days. That's over 2/3 of the summer. That's essentially a heat wave punctuated by slightly less uncomfortable days. We've also got those for extreme precipitation and also for snow-covered days. So you can see in Portsmouth for snow-covered days, traditionally there would be 114 for the historical period. And under the high emissions scenario, by the end of the century, we're looking at a reduction in 95 days, which essentially means almost no snow-covered days for Portsmouth by the end of the century under the high emissions scenario. I think that's over to you, Mary.
Yes, thank you. Okay, so what I'm going to do over the next couple of slides is to summarize the projected change for these tables at Durham, and kind of in terms of some three main key points that came out of the report. So the first would be the extreme heat that Cameron mentioned, as well as warming winters, and then of course extreme precipitation. Right, so starting off with extreme heat, we can see that, as the overall climate warms, the projected summer warming that we expect to experience actually isn't going to coincide with substantial increase in rainfall. So, annual totals show a wetter New Hampshire overall, but that's not going to be evenly distributed seasonally. We see that in the summer, we're not expected to get too much of an increase in precipitation. And so when you combine that relatively small increase in summer rainfall with the greater warming expected during that season, that rainfall is going to be insufficient to sort of offset the increased loss of soil moisture due to the warming temperatures. And so what this does is set the stage then for more of these, what we call sort of rapid onset or flash droughts. They develop very rapidly at the onset of the warm season or the growing season. And so these are the droughts that we've had over the past 2 summers. And so even though overall our climate is expected to get wetter, it's not going to come during the summer months, which then puts us at greater risk for these sort of short-term summertime droughts like the ones we've been experiencing in the past couple of years. And then as overall summer temperatures increase, the extreme temperatures are also expected to increase. And so what we're going to see is the warmest daily temperatures increase, including an increase in the frequency of hot temperature extremes, as Cameron mentioned, like the number of days that exceed 90 degrees Fahrenheit or more. So just to kind of as an example, again, like using the table here, we can see, so Durham averages about 11 90+ degree days per year. So for reference, we had 17 this summer here in Durham. And so as we go forward in time, we can expect the occurrence of these hot extremes to increase. But again, we see the difference between the two projections. So if we do mitigate and kind of stabilize atmospheric concentrations, or we don't, we can see an increase of 17 or more days above 90 by mid-century compared to, for the lower emissions, compared to 27 more days projected by mid-century for higher emissions. And of course, that spread increases as you go further into the century. So moving on to the cold season. So again, warming is projected across the board for all seasons, but the greatest rate of warming has been occurring in the winter and will continue to occur in the winter, particularly at night when those lowest, so those most extreme cold temperatures occur. And so as average winter temperatures warm, we can expect the frequency of cold extremes to decrease. And, and again, that's important, not just for the winter season, but also for the summer season, because again, this is kind of what controls pests and invasive species and weeds and things that are a problem during the warm season. So just to kind of give another example for Durham, we have about 150 nights per year where we see below freezing temperatures. But we can expect 25 to 35 fewer freezing nights by mid-century, again, depending on the emissions. And so with fewer nights below freezing, this can have all kinds of implications, including, more mixed precipitation events as we kind of drop a little bit below freezing or at freezing at night, but then we warm up above freezing during the day. We can also expect more rain on snow events, less overall snow, and fewer days with snow on the ground. And then, of course, as the winter season gets warmer and shorter, the length of the growing season overall, which we define here as days with temperatures that stay above 28 Fahrenheit, that's that hard freeze temperature. And so, as we get our milder winters with less snow, the growing season is going to expand anywhere from 3 to 5 weeks by mid-century across the seacoast region. All right, and then next we have our heavy precipitation or extreme precipitation. So, like temperature, precipitation is projected to increase, but the largest seasonal increases are expected during winter and spring, with very little change expected for summer and fall. And so just like what we've seen over the past 50 years, the increase in total precipitation seasonally are largely due to the increase in the frequency and intensity or amount of extreme precipitation events, which we generally define as 1 or more inches of rainfall in 24 hours, or for the heavier events, the 4-inch storm events that are usually multi-day events, 2 or more days. And so again, looking at Durham, kind of representing the seacoast region here, it's again those larger events that are expected to occur more frequently with time. So for example, the frequency of daily events that produce 2 or more inches of rain in 24 hours could double by mid-century, even if we do stabilize greenhouse gas concentrations by mid-century. So this is kind of the change we can expect, just kind of the baseline. And of course that increases if we don't mitigate. And then of course, the most extreme precipitation events that are 4 or more inches may go from, the average of 3 events per decade, which is what we tend to have now, to 5 or more such storm events by mid-century, again, depending on greenhouse gas emissions. And so this combination of projected increases that we do expect kind of in that winter-spring transition period, increases the risk for the late winter, early spring flooding in terms of both the magnitude of the events as well as the frequency.
Thanks, Mary. It's clear to us from a detailed analysis of the best meteorological data that we can get our hands on that we're already seeing climate change throughout New Hampshire. The biggest impacts, again, coming in winter warming and winter nighttime warming, but we're seeing it in summertime. We're seeing it in these short-term droughts, and we're seeing it in an increase in extreme precipitation events. And so in some ways, I guess what Mary and I want to say is what's been happening is what's going to continue to happen in the future. Where I guess there's nothing really new here, except to the extent to how much warmer and wetter and extreme precipitation events we're going to get in the future. And again, the future really depends on us. But we are looking at for sure a longer, warmer growing season. And as Mary explained in some detail, with an increased risk for this short-term drought during the summertime, which we've already been experiencing, right? And so that certainly has challenges for our agricultural system and our farmers. It has challenges for people growing stuff in their backyards. It also has some significant challenges for water supply, especially for those residents in New Hampshire who are on shallow wells. Who rely upon that rainfall to sort of replenish that groundwater during the summer. That also combines with if we have sort of a lower snowpack and more rain on snow or rain on frozen ground in the winter as those warm up, less of that water might be making it into groundwater. So there's some details that we weren't able to project and model out in the future, but they do present some concerns on water supplies going forward. And we think that is really going to be a significant summertime issue. So I already sort of got into the second one, right? Milder, wetter winters. It's going to affect, I would argue, a lot of our quality of life across New England. We are used to the seasons. We are used to cold winters. And we're used to the recreational opportunities that they provide. And also cold winters, as we've mentioned on several occasions, end up removing sort of pests and weeds that provide problems sort of to vector-borne disease for humans and to affect our agricultural systems. And winter recreation, certainly, in terms of, my favorite winter sports of playing pond hockey and skiing. Also going to affect snowmobiling and ice fishing. And also, if the lakes aren't freezing as much and the rivers aren't freezing as much, that's potentially significant impacts on our ecosystems as well. And then in addition to that, even though we're expected to get more short-term drought, we also project more flooding because of more extreme precipitation events. And so you might think that those two sort of are opposite, and they are, but it is because we don't see an increase in this precipitation in summer. None of the models show that increase in precipitation in summer, but they do show an increase in these extreme precipitation events. So much of the increase in precipitation is coming from bigger events. And a lot of that does run off. And so we have to be careful in terms of many of our communities, which are we tend to settle in valley bottoms, close to rivers. And so we are certainly vulnerable and at risk to flooding. And while we haven't covered it in this report, Mary and I also worked on a report on coastal flood risk, and our seas are going to be rising. So flooding is going to continue to be an issue for our coastal communities. And so I think with that, we'll wrap up our formal comments and take some time to answer your questions. And our hope is that while we've sprinkled this conversation with these highlights of why we think this is important, and perhaps also get into a discussion of what we should be doing about this.
So I would encourage all of our attendees, please drop some questions into our Q&A feature or into the chat feature. I'll get us rolling with a quick question as some of our attendees think about what they want to ask. does New Hampshire, and maybe it's not a unique challenge, but does New Hampshire present kind of a different challenge in that, we have, we have so many different regions that really do look quite different, geographically, and just thinking about the mountains versus the seacoast, versus a bit more inland, like, a Keene, as opposed to states that maybe are in the plain states that might not quite have the same geographic diversity that we have in New Hampshire. So are there unique challenges that we're facing in a state like this or other coastal states?
Yeah, there are challenges, but I mean, personally, as a scientist, I find the geographic diversity. I'm a geographer, so I find that to make it more interesting to work. And also our diversity, I think, does kind of help us because, I know folks who are state climatologists, of course, in the plains, and their issues, they might have, less of a diversity of climate change impacts, but that just kind of magnifies the influence of things like drought on agriculture. And so I think our diversity protects us in a certain way, or, reduces our vulnerability in some respects. But yeah, there's a lot of different things going on, and you have a lot of different communities, a lot of different stakeholders who have different needs that need to be addressed.
So one thing I'd add to that, and I think this is, as we think about this sort of globally, one of the things that New England is going to experience is a slight uptick in precipitation. We're going to get a little bit wetter, but again, more extreme precipitation. And so that's consistent across the region and kind of consistent across mid-latitudes. Wetter areas are going to get wetter and drier areas are going to get drier. And so I think one of the things that especially northern New England is going to have is fresh water. And that's going to be really important in terms of any adaptation that we need to make to climate change. We are going to have water to deal with, even while we experience these shorter term droughts. And so we don't see a huge diversity. I mean, precipitation varies considerably across region, but we see New England getting wetter, and that's very different from what's going to be happening in California and Arizona and Colorado that are already experiencing at current global warming levels, right? Extreme drought, water battles that may turn into water wars soon. And so sort of opposite of the diversity, we're going to have fresh water, and that's going to be really important as we figure out how to deal with this. And then just one other piece on that front, one of the things that hasn't entered the conversation a lot, but I think we need to start thinking about is what happened when people don't want to live in areas where there's no water. And New England is probably going to look very attractive to them. And so in terms of diversity, we have areas that have sort of, lots of zoning in the more sort of southeastern part of the state, where populations are greater. But as you get into the more rural areas of the state, there's less zoning. And you could imagine wealthy individuals coming and buying up big tracts of land and moving here. Or we could imagine a landscape, which we modeled a few years ago, of sort of 5-acre lots going like not up to just through to Winnipesaukee, but all the way beyond. So in some ways, I think sort of the diversity in our social systems is something that we need to take into account on what we're going to do if people decide that they want to come to New England to move here and there's not enough housing stock and they have enough money to build houses.
Yeah, it's a really great point, Cam. And I'm going to come back to that because I have a few questions related to some of those implications. I want to jump to some of the folks who have been attending. So the first question that we have here is related to local communities and whether or not the two of you get questions related to local communities. They wrote, think globally, act locally. So I guess as a follow-up to that as well is if you two are not feeding those questions from local communities, are there places that, if folks want to do things locally, who should they be engaging with? Where could they focus those questions? Anything along those lines?
Yeah, I'll start. As a state climatologist, I'm kind of a natural go-to. That's actually kind of why there's a state climatologist. So I field a lot of those questions, but there are also other organizations that work with communities too, are the UNH Cooperative Extension and Conservation Districts. are on the ground working, doing a lot of great work at the local scale as well. And I work with them, they work with the public, I work with the public. So yeah, that's a big part of what I do. And that's a part of also what went into this report and why we kind of drilled down to some of these local level tables. All of those numbers were intended to inform activities at the local scale.
Yeah, so to add to that, the nature of this report was driven by requests that Mary and I have gotten over years for local information.
Yeah.
And so sure, you can go and read the Intergovernmental Panel on Climate Change report about global climate change, or even the National Climate Assessment, which has a section on the Northeast, but it doesn't provide the detail of information for sort of local municipalities to act. It's more of a general picture and certainly worth reading. But this was really a response to that request for local advice. And I would argue that between Mary and I over the last decade, we have done hundreds, maybe even bordering on 1,000 talks across New Hampshire and New England, and happy to do that. However, I really want to emphasize that we've laid out the climate information in this report. We're happy to talk about it. We're not the individuals who are going to identify the solutions for your community. We're happy to be part of that conversation. What's really important, and what I see happening with the groups I'm talking to, is I sort of insert the climate information, and then there's a broader discussion about, well, what are we going to do about it? And I can be one voice in that. But what's really important is you need to have lots of voices in that conversation. So this report, or Mary and I talking to you, can inform that conversation, but we're not the solution people. I think pretty firmly that those solutions need to come from community conversations and what is right for that community at this point in time.
Another question here related to translating the data. So the question is anybody translating this data to potential impacts on local food production, blueberries, apples, lobsters, et cetera, winter activities lost, revenue, homeowners insurance, et cetera? Make the numbers so that people understand the impact on their lives.
God, it sounds like a proposal ready to write to get some funding. So some of that has been done, not a lot of that has been done, and it tends not to be sort of site specific. Those are all really good questions, and they were sort of well beyond the scope of what we did. But let me take one or maybe two of those, and then Mary, you can jump in. So neither Mary or I are ocean scientists, but there's a lot of ocean science that has been done looking at why there's this boon of lobsters right now in the Gulf of Maine, and why there aren't many lobsters down in Rhode Island or New York, or even now Massachusetts. And so there's this paralytic shellfish disease that attacks the lobsters, and it seems to be connected very closely to warmer temperatures. So we know the Gulf of Maine is one of the bodies of water in the world that's warming at the fastest rate, and the lobsters are essentially migrating northwards. And so that's Maine's sort of gold mine right now. However, the research suggests that those lobsters are going to keep going north to Canada. And so right now, the majority, I think the numbers greater than 90% of the income from the fishery in Maine are coming from lobsters. And there's significant risk there in putting, all your eggs in one basket, all your boats that are lobster boats, as those lobsters begin to migrate out of the region. It is really difficult to sort of pinpoint when that's going to happen and what the economic disruption is going to be, but the general storyline is there. And then also our colleague Liz Burakowski has worked extensively with an organization called Protect Our Winters, and I point you to their website, and they've done a national report on how changing winters will affect the economies in every state in which there is alpine skiing and cross-country skiing. And so they've looked at the hard numbers, they've looked at how that changes over time, they've looked at the cascading impact of skier visits on sort of, hotel rooms and people buying gas and food. And so in that sense, the impact on winter recreation has been well documented in those Protect Our Winter reports. Over to you, Mary.
Right. Yeah. Kind of going from the science to sort of the policy and impacts requires expertise that I know I personally don't have. I am not an economist. So that type of stuff requires, kind of collaborating with other folks. But, there are some kind of more general regional scale studies. I was one of the co-authors on that National Climate Assessment Northeast chapter. And so we refer to, several, some of the peer reviewed literature, of course, on the Northeast skiing industry, as well as some of the agricultural, the specialty crops, blueberries, stuff like that. So there's some, kind of larger scale, regional scale work that's out there, but that's kind of the next step from having all of these climate data that we've compiled, would be to kind of go and work with other folks to try to get some of these more local and state level scale impact studies that can tell you, what the economic impacts of some of these climate impacts are going to be.
Yeah, I guess I just add on top of that, it's hard to do those impacts in a general way. So science might take a general view and, if this, then this. So, like one of the conclusions is that we're likely not going to be able to grow cranberries in New England, or at least southern New England, because there's not going to be enough chilling hours. But those tend to be very site specific and require sort of detailed analysis. So it's a wonderful opportunity for partnerships that say, I need to know how many more years I can grow cranberries here. And that could be a detailed analysis for a specific location that could be extremely valuable for a particular farmer.
It's interesting. I mean, it makes me kind of go to, kind of what are the policy or, public kind of solutions that we could come to if we know, certain communities are going to lose this, other communities are going to gain this. I mean, I think the lobster example is a really perfect kind of visual example, because we could see that happening. It feels really tangible. And obviously, when you think about investing in infrastructure and you think about, making longer term investments, these things need to be taken into consideration. I'll get back to that in a second, but a question just came in that's related to what you were saying, Mary, as far as collaboration. So the question is, do you collaborate with the other 5 New England states? That's where it ends, but obviously we could expand on that in either drafting these reports or in thinking about solutions, kind of all of these things. How much collaboration is there in New England?
There's a lot of collaboration. I know I personally work a lot with the state climatologists in both Maine and Vermont, as well as some of the USGS folks, the hydrologists that are up in Maine. A lot of us all first met working on the Northeast chapter of the National Climate Assessment. And so we can, kind of kept a lot of those collaborations rolling, focusing on a lot of the rural northern New England impacts. We've noticed in the literature, there's a lot of work that focuses on urban areas and coastal areas, and the kind of the northern rural areas don't get as much research. And so we're kind of working, at least that's been a lot of my work, has been focusing on those areas with my other rural New England climate science colleagues. And I know, Cameron, you've been working a lot with folks on coastal issues, right?
Yeah, I think the coastal issue is an interesting one. So we have the New Hampshire Coastal Adaptation Work Group, which has been working on this issue, and we connect with partners in southern Maine, and I help drive that collaboration because I'm of the work that I'm doing in Kittery. However, every coastal state has a coastal program that's funded by NOAA, and those specialists actually work together, sort of thinking about how we can address the issue around sea level rise and storm changes in storm surge and groundwater rise in our coastal areas. So there is sort of, I would say there's a level of collaboration among scientists, and maybe we can sort of say around some particular boundary spanners. I think that New England suffers from a significant lack of collaboration, not through the scientific community, but more so, I think, through the policy and local government community. I think there's some wonderful lessons to be learned, for example, from the Massachusetts Vulnerability Assessment Program that they've been running now for about 5 years for communities across New England, and that can be shared. We do at UNH help run this program called the New England Municipal Sustainability Network, where we engage about 25 municipalities in really addressing these challenges in building resilient and sustainable communities. But there's way more than 25 communities across New England. And then one other point here, and this has been something that I think policy people have thought about for a long time, is that if New England got on the same page on climate change, we have 12 senators that could really help drive this. And so that notion of New England could really be a leader, not in terms of the House of Representatives because of our population, but because the senators of driving this forward. I've been living here now for over 3 decades, and it's rare that you see sort of the New England delegation coming together at the federal level and really making a difference. And then I guess I should also mention there is this organization that early on was very active in the issue of climate change and reducing greenhouse gas emissions, and that was the New England Governors and Eastern Canadian Premiers. And out of that, we had sort of programs like the Regional Greenhouse Gas Initiative, which was a cap and trade program that went beyond New England down into other northeastern states that helps reduce greenhouse gas emissions from the electricity generating sector. So there are some pretty significant examples of New England collaborating, and I think we need more of that beyond the scientists.
Yeah, they're really, really great points. And I mean, I think, and correct me, I think Reggie went down as far as, I thought Virginia signed on in the last. Is that crazy, or did that happen?
No, I think they did.
Yeah, I mean, I think it was drifting pretty far down into the mid-Atlantic, which was really cool to see. You know, and this is a problem that we have across government in any number of different areas, where the idea of just sharing information, sharing services, you know, thinking about problems beyond our borders has always been, it's always been a challenge, right? Even at the municipal level, because so many of the challenges we face in the public sector aren't limited by these, you know, relatively arbitrary borders in certain scenarios. So I think, you know, thinking about those solutions is really, really key to this. A question related to kind of these extremes in the weather versus kind of just the averages, right? So if you look and you're like, okay, the average is going to shift, you know, 4 degrees. We're not really talking about kind of a consistent temperature anymore, though, are we? We're kind of talking about challenges and predictability. I mean, I don't know how this affects, you know, climate science and how you do your job, Mary, but I mean, could you tell us a little bit more about that? I mean, this isn't just like it's going to be 20 degrees every day in the winter as opposed to it being, you know, 16 degrees every day.
Right. So climate change is kind of a multiplier. And so what it does is it, you know, exaggerates the extremes, both in terms of the physical science as well as the social vulnerability impacts. But as I like to think about it, so we talk all of these average temperature increases. What we're really talking about is energy that's being held in the atmosphere, energy that can do things like heat, you know, make it feel warmer. It can also evaporate moisture from the air, or from the ground, and put it into the air to create more rain. And so when we talk about these average increases, you know, that's just more energy in the air that can exacerbate the extremes. And so that's why, you know, as our climate overall warms, we're seeing more of these extremes events. So not just storms that produce more rainfall, but, you know, stronger winds, you know, deeper lows for those coastal storms that come up here. So it, you know, makes the extremes that much more extreme. So heavier precipitation gets heavier, drier times get drier. And again, so this is all kind of related to thinking about the climate systems in terms of energy as opposed to, you know, temperatures. And so that's kind of the way I think about the system. And then, of course, when it trickles down into the impacts, again, it's going to exacerbate some of our social vulnerabilities and have greater impacts on certain populations as opposed to others.
And I can add to that. I think as scientists, we think about sort of the energy of the climate system a lot. It's probably not how people who are not climate scientists think about it. But a couple of examples. Well, one comment, first of all, is that we tend to have much more confidence in changes in the mean than on changes in the tails of the distribution. And so what we've tried to do in this report is identify both the changes in the mean, but also the changes in those extreme precipitation and temperature events, like days above 90 degrees Fahrenheit. And you're absolutely right, Dan, it's not linear, right? So the classic example for New Hampshire is our annual precipitation goes up a little bit, but the frequency of big storms, 4 inches of 48 hours, goes up like almost doubles, right? So so you're looking at a 5 to 10% change in annual precipitation, but the distribution of that precipitation is really important. And we know now, in part, it's driven by the fact that the atmosphere can hold more water when it's warm, so more of that can come down. The other example that might be perhaps a little more frightening is how strong Hurricane Fiona was as it made it up and hit Canada. Right, so that has really important lessons for us, is that warm sea surface temperatures allow these tropical storms to maintain their energy, and in some cases, maybe even enhance some of their energy. So biggest storm, lowest pressures to ever affect Atlantic Canada in the period of record, right, Fiona. And then we saw with Ian how it rapidly intensified as it went across really warm sea surface temperatures in the Gulf of Mexico. So, the sea surface temperatures in the Gulf of Mexico were 90 degrees Fahrenheit. I mean, it's unbelievable from an energy perspective, how much energy that represents. And so that results in a much, much stronger storm, right? Ian went from a category 1 to almost a category 5 from Cuba before it hit Florida. And so there are lots of these sort of non-linear aspects to the climate system. And I think the question is really well placed in, we have to look at the sort of the changing averages, but the big impacts are likely going to come from these changing extremes.
And just to kind of add on that too, with the variability that you mentioned. And so when you look at some of the averages, so I said, the growing season is going to get longer. Well, some people might see that as a good thing, right? But we still, again, will have those, cold weather. So we can still get that hard freeze in late April. So having an earlier growing season, with all of the weather variability that is in between, some of the perceived benefits that we see in the averages might not actually play out, probably won't play out.
Yeah, that's really helpful. If there are any other questions out there, I'd encourage you to drop them in. I'll kind of finish with one kind of larger question that, I recognize that this doesn't necessarily fall into either of your expertise, but based on what the two of you are seeing. So Mary, the point you just made about, okay, so we might have this longer growing season, but that also might be, spattered with some, below freezing, temperatures that actually don't help us from an economic standpoint, as far as, okay, let's just start, growing things that require more time, et cetera, right? That change the way that our agricultural landscape looks. And Cam, you had mentioned, right, New England might be an attractive place for folks to move and, take advantage of some of the resources that we have here, the natural resources that we have. So if we're able to say, right, there are certain things that we, that we know we could do to help mitigate, climate change and some of these challenges. There are certain things that at this point, we know your, best guess in this low scenario is this 4-degree increase. In thinking about industries and thinking about infrastructure, in thinking about, economic effects, where do you kind of point your, arrow as far as, look, we need to do this to get ready for this, or, we need to have this infrastructure in place? Is there anything that's just, highlighted for you as steps that we need to take as a state, as communities, as, just members, residents of this state? So I'm just curious to hear both of your thoughts on that.
Yeah, I'm happy to jump in, and this is a conversation that I think we could have for days, weeks. So I'll try and keep it short. So 2 things: I think we have to be able to walk and chew gum at the same time, which means we have to learn how to reduce our greenhouse gas emissions while adapting to the inevitable climate change that's locked into the system. And so, I think it's really important for us to stop having the conversation about, are humans changing the climate, to how much, to how is it that we're going to address it. And, from my understanding of reading the economic reports, there is tremendous opportunity in transitioning our energy system to renewable energy. Not only there's way more jobs in renewable energy now than there is in fossil fuels. And by the way, there's very few fossil fuel jobs in New England anyway, to start with. So creating our energy from the sun and from the wind and from the water and from the ocean and from our groundwater just makes a lot of sense. It's going to require lots of investment and big infrastructure change. So let's grab that opportunity and let's become sort of a focal area for renewable energy. And then I think there's also an opportunity, especially because of the local control issues in New England. Not every community is going to adapt the same, the coast and inland and the mountains. And so what's the opportunity to strengthen those municipalities and those regional planning agencies that can hold these conversations so communities can then really sort of figure out what they can do. So I see this opportunity not for government to become bigger, but for municipalities to be a focus area to engage communities in what they want to do. And then last but not least, sort of from our personal lives, I think it's really important for us to act individually. So we should be coming, right? How is it we make our homes more efficient and the way that we sort of move around? So, you know, there's EV cars and there's all kinds of things you can do with heating systems, but I'll give a big shout out to heat pumps, which I use in Kittery, and they're fantastic. But we can't stop there. Individual change is not going to solve this problem. We need to act in the places where we work. So University of New Hampshire, we've been working for 25 years to significantly reduce our greenhouse gas emissions, and we're 50% below our greenhouse gas emissions in 2001, and we're continuing to reduce those. And then we also have to work in our community, and whether that's your religious community or the places where you work out or just your neighborhood, we need to work in sort of all three of those areas in order to really drive the change. And I'll come back to where I started. I think New England can and should be a leader in this space. And the challenge is, and as you mentioned, it requires us to work together, which seems to be more difficult than it should be.
Yeah, so second, all of that. But, you know, just to kind of build on that too, a lot of times we think of, you know, adaptation and mitigation activities as two separate things. When if you kind of take more of a holistic view of things, we can actually kind of address them both together. So, I mean, Cameron, we brought up the, you know, renewable energy infrastructure. You know, that is, of course, going to, you know, act toward mitigation, but also it is an adaptation effort too, because the more the less we're relying on, you know, maybe a large scale grid or fossil fuel based power, you know, the more resilient we're going to be in terms of, you know, getting through the big storm events that we know are going to happen, more of the icing events we know are going to happen as our winter warms. And so I think kind of tackling things, I guess, together and kind of thinking them as all working toward the same means kind of maybe makes it a little bit more, I know, easier to think about and also easier to implement at, you know, ranging from local to even regional levels.
I'll just add one more example here, and it has to do with natural ecosystems. We should really be preserving what natural ecosystems are left across New Hampshire and New England because of the superb and amazing ecosystem services they provide. And perhaps the highlight there is along this lines of both adaptation and mitigation together, is the notion of salt marshes. So yes, they protect us from big coastal storms. They're really important. They're really important fish nurseries, and they absorb an enormous amount of carbon. So if we could actually preserve them as sea levels rise, provide them with an area to migrate inland so they continue to exist, we can actually suck more carbon out of the atmosphere in those ecosystems than in our forests. I mean, it is amazing how much carbon is stored in those. And what we don't want to do is destroy them so that carbon goes back into the atmosphere. So there's a mitigation aspect to that, yep, right? We're taking more carbon out of the atmosphere. There's an adaptation aspect to that in that these are really important coastal buffers to reduce the impact of storm surge. And they are, you think about sort of the Rachel Carson preserves, right? The recreational and the spiritual opportunities that are provided by these incredible landscapes, especially now, sort of as they turn that golden brown and you go to the beach at sunset. I mean, they're just spectacular and they scream New England. And so like there's big efforts going on, but we need to enhance those sort of across the region in terms of preserving those ecosystems, not just because they're nice, but because they actually provide the soil and the food and the oxygen and the opportunities for recreation that humans require to live.
Thank you to both of you, both Mary and Cameron, for joining us this morning. Thank you so much for the work that you guys are doing in this space. And, you know, I would also just say thank you for the work that you're doing at UNH as well in this space. You know, there's just a lot of education that still needs to happen and happening with our undergraduate and graduate students at UNH. So just, you know, for everyone out there to know, you know, this is part of what Cameron and Mary do as well at the university, right? So thank you for all of that work. It really is just much needed work. You know, and we look forward to everyone engaging in this, right? I think as Cam, as you've been saying, right, these local solutions need to come from, you know, local communities. And folks at UNH and other scientists and researchers can share information, but it really is kind of incumbent on all of us to engage in that process. Let me just take a quick moment to promote what we have coming up next. So in November, we have the New Hampshire Community Action Programs, and we'll have a panel that will be talking about community action programs, the benefit the public and how they benefit the public and why they're important to gain some public dollars. And then after that, we're going to be doing a bit of an election recap from the November election. We're going to have Dante Scala, political science at UNH, and Andy Smith, the director of the Survey Center at UNH, giving us a recap on the election. So that's November and December. So once again, thank you to our two guests today. Thanks for jumping on with us. And thanks to everyone else who joined in this morning. We look forward to continuing this conversation in the future. Take care, everybody.